It's like a Hollywood movie kind of video, it starts with 20 lines of code, present. We're good. All right, perfect. Welcome to this talk about, well, I called it More Awesome Java Applications. I called it 5 Tips to Make More Awesome Java Applications. It's different names, different things, but the idea is to talk a little bit how we can make our applications a tiny little bit better, because we usually develop applications in, lately we've been doing a lot of web applications, RESTful applications, and all this kind of stuff, and we've been talking a lot about microservices. We've been talking about all that. We've heard a lot of talks about, you should split up the monoliths, you should put them in tiny little microservices, you should do this and that, and all these kind of things. But there are some things that we do not talk much about, and I kind of see that in my daily job. I work as a consultant. I live and work in Oslo, Norway, and I see all these kind of things happening a lot of times. And I did this talk, first time I did this talk, it was 2 weeks ago in Dublin, for Dublin Java User Group, and then when I did that, there was people coming to me and saying, thank you very much, this is exactly what we needed, because this is exactly what we're not doing at work. So at least I helped at least 1 or 2 people already. That's a good thing. So if I hope I'll get maybe a few more people here as well. I called it 5 tips, and we, as all programmers and all that, we start counting from 0. So you get a little bit of introduction before we get to 1. The thing is, a lot of people talk about Java. It's like, oh, well, there is a lot of boilerplate code and this and that and blah. And, some other languages, they have batteries included, all the kind of packages that are following that are there that you don't need to install something extra and stuff. And Java doesn't have that. Well, kind of Java has had that. And that was called different names. It used to be called Java-E, J2E, Jakarta-E, and so on, so on, so on. And that's pretty much it. So you see that there was a lot of things that's been added throughout times, throughout versions of what now is Jakarta-EE. And it's been a lot of things coming, and there's a lot of things that we use now, or we need to use now, if we're going to build those RESTful microservices that I was talking about. There was things like it started with, well, not started, but it included things like dependency injection. It was some security stuff. It was some JSON stuff, and so on, so on, so on, right? Now we are at Jakarta 10, and it has all those things that you see there and some more stuff. And it's been also a refactoring in this thing called microprofile. So there is this addition, or it started as an initiative when Jakarta-EE, or Java-EE back then, wasn't really active, and then there is this thing started called microprofile, which was a kind of opinionated mix of tools that you might want to use when you build microservices in Java. Simplified, smaller version of this is what you need, this is what we think you need for developing microservices. Now with this latest version, 6th version, it's been a lot of those boxes. There were many more boxes that you see on top there. A lot of those boxes kind of got converged into one thing called Jakarta-EE 10 core profile. And then there are a lot of things on top as well that is not a part of Jakarta-EE, but they still add some things. Like, for example, I don't know, a REST client. That's a good thing to mention, because when you talk from your application to another web service, you don't want to write all the HTTP handling and parsing and all that. There is a REST client for that. Or you don't want to do metrics or anything every time you do it. You can use the libraries for that. In case you wondered what Jakarta 10 EE, Jakarta-EE 10 core profile is, that's the list, that's the spec. And you can find the spec. There's a handy short link on the side there. But, well, I don't expect you to type it all that. You can just search for it. Now that I've given you a little bit of introduction of, those things that we can have in a typical Java application. So what is the thing that make our applications actually better, or what can make it better? One of the things, when you create the modern applications, when you do the modernization kind of thing, is that you need your application to be resilient and to be able to handle errors. So what happens to your application? Say you're dependent on another web service. It's a web service that you do not control, you do not have any control over. It's just an endpoint. What happens if that thing goes down? Your application goes down in flames, or you just kind of forward the error message saying, stack trace something, long thing, and then you just return it to user, or you just keep on spinning and no responding. What's going to happen, right? So one of the tips of making applications better, one of the things that you should think about is thinking about fault tolerance. How do you handle it, and how do you want your application to behave? So basically, what happens when something you rely on fails? Why do you want to do that? Well, like I said, the service you're using is failing. What do? Do you want to just ignore it and just do try catch and nothing, or you want to call another backup service? Maybe, I don't know, say for example you're using a web service providing some weather information. It's very precise, very good, but it's flaky. It just goes up and down sometimes. I don't know, it just happens like that. But then you have another web service that is much less quality of the data, but it's more stable, or it's just failover. So if that flaky one fails, you just want to sometimes seamlessly just go over to another one, return the data. User is still happy because he or she got the data they wanted, but maybe it's not as precise, but it's okay. They got something. Another thing is that we've seen a lot of examples of applications being unresponsive and actually DDoSing themselves, because one part of application go down, all the other parts of applications start kind of requesting and asking about something, and you basically DDoS yourself. I mean, your application is filling up the network, filling up the disk request, all these kind of things, and then everything grinds to a stop. So what do you do with all that kind of things? Well, I mean, one of the ways of doing that, there are several ways of doing that, but one of the ways is to have a look at microprofile fault tolerance spec, which is linked down there again, a very long one, but the point is, you can find it online. So what you can do is actually you can annotate or add some things to your code without doing actually too much of a work. You just can define things like timeouts, how fast your application should give up on trying to get some reply for something, how many times it should retry, is there a fallback solution or not, is there like a fallback service, introduce circuit breakers, so if that happens so many times, do what? Stop doing that, call something else, all this kind of functionality. There is also a bulkhead, basically like you have on a ship, where you just close doors and then let the damaged area get flooded and then don't flood the rest. So you can do that. And there is also a synchronous where you can specify if it should be synchronous or asynchronous. I'll show you on a simple example at the end of the talk how it actually works, but the idea is you can actually say, hey, if this service is failing, if there is not HTTP 200 coming back but something else, cool, pretend nothing happened, go to something else, go to another service. The static version of the code I will be showing you, a little bit simplified version of the code I will be showing you, this is how it is. So this is a REST client that I have implemented. So I have two endpoints. There is one responding at API. You see I have the path defined up there. It's API/message and API/message backup. And if message fails, I have specified fallback, which will just go to the other one. That's it. And here it's just the method headers, method names, because this is the REST client that will be using a web service living far, far away at localhost 8080. That's how you do when you develop demos. Everything is in localhost, but it's actually two different services and so on. So that's cool. The way you actually simulate, so what I did was I had to simulate a failing service, and well, of course, me, like everybody else as developers, we never write bugs, so I had to, introduce a bug on purpose, because, who writes buggy software, right? So here I roll a dice, and every time it's divisible by 2, I just fail. Actually, the other way around. I changed in the code later. It's now it's failing when it's divisible by 2. Here on this code, it's the opposite. If it's actually divisible by 2, it's happy. Yes, question.
I'm sorry, is it possible to dim the lights?
If it's possible to dim the lights, let's see. Yeah, I'll keep talking, and then yeah, thanks. It's a bit difficult to see. It's a good point. So the message method is, you see there, and it just returns some kind of weird error sometimes. And to make this, is it better? Oh, thank you so much. Thank you. Yeah, and the backup method is just basically returns a backup message, a backup hello, so you can actually see when something is failing and when something is not. Like I said, there is a bunch of other things you can specify, and right now I just used only failover, and this is how it looks on the client side, or well, backend of the web service side. Another thing that I really want to talk about is health. So we talked about handling errors, handling things going bad, but how do you actually measure how your application is doing, what's happening inside it? Do you know that your application is CPU intensive, memory intensive, whatever, like disk IO intensive or something like that? Do you have like thresholds? Can you actually report those thresholds and tell somebody outside? I hope it's not a human being. I hope it's some kind of Kubernetes something or something doing automatic monitoring of all that, but tell that thing or human being that, hey, I'm not really doing well, I might fail soon, do something about it, spin up more of us, give me more memory, give me more CPU, whatever. Yeah, well, sorry for a really bad pun, but what's up? Why do you need health? Health is many different things. So one of them is your container up and running? But your container up and running doesn't mean it's actually is able to receive requests already. So the container is up, but maybe you have a super fancy application that needs to read a lot of stuff and put into memory or something like that. And then you need to wait for your application to start as well, right? So that's the thing. So container being up, your app actually inside the container being up, and you need to know how the application itself is doing as well to be able to know when to scale and when not to do that. Because you don't want to use too much resources unnecessarily, but you need to scale just in time. So again, users do not see all that magic. The less they see of the back office work, the better it is, because they're happy. It just works. It's just amazing for them. So there are a few things again. So I'm going to show you again. So this is one of the, again, microprofile things. Not all of the tips going to be about microprofile, but this one is. So this one is health, and there is a spec, again, down link at the bottom there. All of the things that I'm showing, all of the things that I'll be showing that concern microprofile, they're actually specs. It's up to providers who say they're compatible with microprofile to actually implement that. So I'll be showing, the demos I'll be showing will be on Quarkus, but there is a bunch of others providers as well that have, like, there is Open Liberty, there is what else? Helidon. There are a bunch of others that do support a lot of those things that I'll be showing. So, readiness. Are we ready to serve the requests? Startup. Have you started up as an application? And liveness is something that you can ping sometimes your application and ask and just like poke it and say, hey, you're good, you're fine. And then you can define your own rules of what is actually fine. It can be, I don't know, HTTP response codes, right? If it returns anything that's other than 200, then probably something is up. Or it can be delays. So it can be things like latency. So if you get your application above some kind of latency, then there is something fishy. So you need to do something about it. So that's the health part. Another thing, when we talk about measuring things, it goes hands in hand. It's looking at metrics. So metrics in microprofile is a little bit kind of right now topic that there are things going back and forth. But the point is that you need to, very often for your applications, you need to define metrics and expose those to a platform, whatever platform that is running that. It can be Kubernetes, it could be some serverless stuff, it can be whatever. How you do it doesn't necessarily matter. There is a lot of discussions like, should we go with this standard or the other standard and things like that, but the point is you should use something. And there is a lot of things that we, technology, I mean, you've probably heard that on the keynote as well. We really like going really passionate about one thing. Oh, my library X is so much better than anything else. It's not, I mean, don't throw technology at problems. It's actually we people who actually solve problems. So implementations and all that aside, use something that will give you metrics. Why metrics? Well, because it gives you a custom set of parameters that are specific for your own application. Because, you can always implement some standard ones, and they're good, but then you want to have possibly you want something for your own application as well. How do you do that? Well, you can, again, annotations. Quite easy way of doing that is just to throw on, for example, counted. There are some other ways, some other things as well you can do. The simplest one is counted, and then you can provide tags as well to measure. So, for example, in my example that I'll show you at the end, there will be like tag for success and tag for failure, so you can actually see how many times that dice roll thing made my application fail. All right, so and the cool thing is usually that a lot of those things, if you use this spec, if you use something that complies to that spec and you pull in that dependency into your Java application, you will get health at /health. You will also get /health readiness, liveness, and so on. So you can actually specify different kinds of health probes. You can do the same with metrics, so /metrics will also expose that. You might want to be aware of that because maybe you don't want to expose that to the whole internet. Maybe it can be your internal /metrics /health. It can be kind of something you want to keep for yourself. Maybe sharing is caring. It's up to you, but be aware of that. So next thing is not a microprofile thing, but it's an open source project that, like many other many other open source projects, ended up being a kind of, well, we have a company and you can pay us money if you want to use that, but here is an open source, and if you want to run it yourself, here you go. And that is, that's what I'm going to show you. But the point is, it doesn't matter again. I had to pick something to put into my demo. I had to pick something that I kind of liked, and I'm going to show you something called Unleash. It's a really cool thing. It started actually in Norway. It's not the reason I'm showing you, but it did start in Norway. There is the big site called fin.no. Where they started doing all that, and then they were like, oh, this is really cool, let's make a product out of it. So I'm going to show you a little bit of that. But the point here is you can use whatever you want, but you might want to consider using feature toggling, because what if you are developing a big kind of piece of functionality and you're still not ready to push it into production, but you don't want to keep your feature branch living on the side forever. Maybe you just want to push a little bit and a little bit and a little bit, and when you're ready, you just flip a switch and then it just like, ta-da, it just works. Or maybe you just developed only front end, but there is no back end for that, so you maybe want to hide it from the front end page. Things like that is very good examples for feature toggling. I've been working in a really large government projects where people would ask us to do like, hey, we really need this feature because the elections are coming or something. Go, and then you kind of code for life, and then you do that, and then something political, something, you know how it works, right? Something changes. They're like, stop. Do not release. And then you're like, oh, what do we do now? And how do we branch out? Do we like just delete the code? And if there would have been a feature toggle, you could have just said, nope, don't do that, don't show that, and it's gone, right? It's not always just a political thing. It can be just a business decision or anything else, really. But the point is, your feature toggles is a really good way of controlling this kind of things without too much of a trouble, and you can do it by a flip of a actual switch. I'll show you. It can also be a good way of doing A/B testing. So you can say, well, half of my users is going to see the yellow page and the other half is going to see a purple page. And then we'll see who likes which one better, or how fast they leave the site or something. There is a negative testing thing as well. Apparently it's a thing. You annoy users enough to measure how fast they will leave. But I mean, you can do things like that. You can do it based on not even that, you can just do it on geographical location. Just everybody from Sweden is going to see one set of features, and everybody from Norway sees another set of features, and so on, so on, so on. So it's actually a really, really nice thing in many different ways. The feature toggling, obviously you can do it by hand. You can put it in config files. You can do all these kind of things, but maybe you don't want to do that again. It's just like, do you really want to code all these boring things over and over and over again? No, well, there is a library or there is a solution for that. So like I said, I'm going to show you at the end. There's something called Unleash, but feel free to use whatever you like. This is what I landed on. This is what worked for me. This is cool. So the way it works, it's pretty much one line of code. It's a little bit of a lie. I mean, you do need to configure the object that you use for Unleash. You just need to provide some security stuff and some tokens and stuff so you can actually securely talk to the Unleash server. But in reality, it's just, yeah, I mean, I'm really good at bad jokes. So you see what's happening in the code, right? So if I turn on the chaos feature, a bug becomes a feature. And yeah, that's it. It's a simple way of showing you some code and a simple way of showing you feature toggling. What happens if Unleash is down? It's a good point. They do some smart things. They actually have a little cache, because I see it sometimes because everything in my machine runs in small containers. And if my container is down, it actually says something like using cache or using something backup something. But the point is that you probably should have some kind of handling of that as well. Because if that is down, it is not returning you. That's also how they coded the SDK, right? Because it's not returning me like a null pointer or something. So it's not crashing hard, but it might go into default stuff or something like that. But you can maybe consider having some backup failover kind of things, right? Because, for example, the thing that I'm not going to show you, and I'm not going to talk about really, except for now, is this thing called config. And there you can also specify a long set of, and there is a spec for microprofile config where you can actually specify different levels of, okay, on a system level, in the code, the default value is this. And then it's being overruled by a property file. Then it's overruled by another property. So you have a bunch of property files with a hierarchy that can keep overruling and if all of them fail, there is last line of defense that's in your code, which is an annotation saying default value something. I think I have it in my code. I think I had it, so we'll see. That's good. We're good on time, so we'll have some time for code as well. So the last thing I want to talk about is it's a kind of bucket where I put all the other things that people usually do wrong, so like top 5 things for me, what I see. And there I put things like environment, configuration. Actually, I kind of talked a little bit about the microprofile config already, but generally configuration for environments and also infrastructure stuff. So first of all is that I said this thing already, so do not throw technology at problems, try to solve them because we humans actually solve that. It's not just if you throw enough money and technology at a problem, it goes away. Well, you might kind of hide it, but you really want to solve it. And solving that needs sometimes human touch. Another thing when we talk about environments, and especially when we talk about clouds, local cloud, public cloud, anything, serverless, all those kind of things, whatever you're running on, do not do ClickOps. It's very tempting, first time especially when you're getting to use, I'm going to learn this new cloud thing. Ooh, yay. And then you do click, 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 click. Ooh, my app is running. Cool, production, done. And then like 3 weeks later, somebody calls you and is like, can you set up a test environment for this? And then you're like, yeah, well, I'll need like 5 more days because I need to remember where I clicked, what I clicked on, and why it actually worked. And then you spend another 5 days setting up, which could have been just a tiny little script. So do not, please, 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 please do not do ClickOps. And if you do ClickOps once, just to make sure it works, then kind of delete it and create a script. Do something that will make it reproducible. Because then you can actually tear down and create environments fast. Then you actually have a documentation. What the heck happened when you were actually deploying that? And then you will also have a traceability. When you change something, you do not go and actually change. I know it's very tempting, but you should try to look at the web interface console with your hands behind your back instead of like on the keyboard and the mouse, and then actually do changes. There are a bunch of tools for that. There is things, well, this is why, right? I talked about that already. Reproducibility. You can actually create new environments, create new versions of the application or whatever. You can actually even create environments that you do not need all the time. So say you have test environments, you have test period of a week, and then for another 3 weeks, you just develop new features. You don't really need that test environment, that specific test environment, maybe. What do? Well, you just let it run? Well, I mean, we used to do that, yes, but now we can actually tear it down, we can delete it, we can use that infrastructure, that hardware to something useful instead of just warming up server rooms. And then you can actually run that script again in 3 weeks. Everything will be just ready for you, and then you can do testing again, right? So reproducible, documented, automated, because, well, I mean, boring things doing over and over again, it's not that fun. The downside of that, is, and all of those things that I mentioned obviously have downsides. So for this one, it's that you need to maintain that. Like with everything else, if you do feature toggles, please do delete those feature toggles after you're done with them. After you know that this is kind of general stuff, delete feature toggles. Otherwise, you will have a million toggles and you have no idea what they're doing. And can we touch them? Nobody knows. Same here. When you create those scripts, it's not just write once and leave it forever. It will change your operating system versions will change, your software versions will change, your configuration will change, and you need to maintain that. So it will need some effort, but still, all in all, it will make your life a little bit better. There's a bunch of things that can help you with this kind of thing. So infrastructure as code, so there are a bunch of options. Terraform, most of you have heard about. There is also Pulumi, a little bit different approach, but there's also a lot of other similar or less similar products that help you set up things or create new environments or manage those environments and so on, so on, so on. Microprofile, microprofile config, we talked a little bit about already. Infrastructure, I just put it there because you need to consider where do you need to run your application, because it's a lot of times I get questions. I mean, they were like, hey, we need an architect. I work as an architect. I come and like help people to do that. Say, hey, we need an architect. It's like, cool, okay, what can I help you with? Well, we need someone to decide whether we should go with Angular or Vue on the front end. And I'm like, yeah, well, this is not what you need an architect for. You need an actual architect that will design an interface that can talk to those things and actually make sure that those things are flexible and they actually run in a good way. Deciding which product you should use, if it's front end, back end, whatever, yeah, I can help you with that, but this is not why you're paying me. You're paying me to make a solution flexible and nice. And when it comes to infrastructure, I also see a lot of people say, hey, we put things on Kubernetes. I say, why? Well, you know, Microsoft does it, Google does it, Amazon. So our little startup of 3.5 people and one 10% working student, we need Kubernetes, obviously, because reasons. And then you're like, nah, you don't need that. Do you really want to spend money on huge amount of clusters and nodes and everything for your tiny little app that is just like has 3 users? Maybe not. Maybe you want to go serverless. Maybe you want to use some kind of ready product that will scale up and down and actually going to scale it down to 0. I know it's a bit sad, you know, you don't have like Kubernetes, containers. I mean, everybody's running on You don't need that. I did that. I did deploy a tiny little container that was supposed to collect feedback for a couple of days, a year, on a 3-node Kubernetes cluster. I let it run for a little bit because I forgot. That's what happens. Then I remembered it when I got the bill. The bill was not pretty. And then I was like, I think it was something like 1,500 kronas a month that thing costed me. And then I was like, do I really need 1,500 kronas a month for an application that was used for 3 days? I mean, it scaled like hell. 3,000 people, and it just worked. It was amazing. But I mean, all the other 12 months-ish, 11 months and 3 weeks, maybe not worth of 1,500 a month. So the point is, pick your application and infrastructure as specific for your application. So, demo time. And by the way, if you think all those drawings are weird, they are, because somebody, I'm not going to tell any names, but it was this guy, had acute kind of procrastination issues. So yeah, you know, what happens when you can't find the icons you like? You draw them. And you kind of have to like them because it's yours. But yeah, all code, I haven't published that repo, but actually I can do that. I'll do that right after the talk. But I will start with a little bit of documentation. And the documentation is, I mean, for very obvious reasons, we had to do it in ASCII because we could. I could. I did not do that by hand. I'm just saying, I do have a life, but sometimes. So the point is, we have 2 web services. We have web service 1, demo service 1, and we have demo backend service 1. Service A, service B. It has several endpoints, so each of them have a high endpoint, and each of them have a feature endpoint. The backend service also has message and backup message, so it has a kind of API. Very, very stupid API, but it has API, come on. I have another container in there called Unleash, so that's the feature toggling thing, and it is having 3 different features that I can toggle. So one is called very creative. I was very creative that day. I called it feature. The other one I called chaos, a little bit inspired by the chaos monkey, you know, this kind of chaos engineering thing. And the third one was delay, because I wanted to test how it works with the delays of everything. So let's look at some code. And I need to make it bigger. Okay, let's see. We can go. I have a little bit of time, that's good. Okay, let's see. So, first, I'm actually running, so we can do docker -a. In case you wonder, oh, this, okay, it worked. The demo gods are with us. So, I did that, just so you know. It's not actually Docker, it's Podman running in the back. And so I'm using Podman, I'm using Podman Compose. Oh, bigger.
Oh, yes.
Thank you, I will do that. How do you do that? It does not. Okay, it doesn't. The command plus didn't work, but what I can do is to start this. Come on, this one I can make bigger. So docker ps-a. Yeah, so we have a bunch of containers here, right? We have, like I said, we have backend, client, and we have 2 Unleash containers as well. They're all running on the same machine. They are all responding on different ports. Now, if I take this thing away, and I can make this part bigger. Oh, come on. So, what we have here is a little bit of measurement. So I added counted. I defined it as a custom messaging service, and I have a tag which says total, because it's going to be called every time something is being called, because that's API message. We have a little bit of text. I'll show you why in a second, but this is basically a little bit of summary and description and stuff. We're going to use it for Open API in a second. Speaking of documentation and things that you basically get out of the box. Here I have, like I said, we have the dice roll thing. We have 6 options, because 6 sides of a dice. If it's divisible by 2, it will just fail. And it will only fail if the chaos variable is on. Also, if the delay variable is on, it will sleep for 5 seconds before answering. Power nap. We all need that, right? So that's it. And then what you need to make Unleash work, what I said to you to create that object, is just you needed this couple of lines. I did put it into the constructor. Probably not, you know, don't want to do that in your production code, but for a demo it works. The idea is to keep it as simple as possible, right? So let's have a look. We have now a browser somewhere there. And then we can make it bigger as well. We can go localhost 9081. And then we go high. Increase. So what happens is that if I keep on refreshing, it will just say hello. It will never crash. We have a localhost. Closed 42. Standard passwords, that's really good, right? Secure and all. Yeah, no, I don't want to save that. Okay, let's make it a little bit smaller. So what we have here is we have a bunch of variables. So we have delay, feature, and chaos. All of them are off. We have two environments here, development and production. And, well, since chaos is not really on, nothing was happening. So now we turned on chaos here. And magically, if we do refresh, it should start failing at some time. Yeah, they're dead. So now it's just randomly failing at some point. But user is not seeing anything. The only thing user is seeing is actually a different message, but that's because demo, right? I could have just sent exactly the same message, it would be just fine. If you want to see at metrics, you can actually see it's a little bit messy. It's a lot of things happening here, but what I want to look at, so there is so we don't have it on this one, obviously, but because this is a backend issue, right? This is a backend failing. So here we have, at 9082, we have the backend running. And here we can actually see that we have a counter that has been counting how many times the message has been called in total, 65 times, and 14 of them was failed. So you can do all these kind of things. This is a very simple way of doing this in my case, because I was just annotating that with counted, purpose total, and the other one, the failing one, was purpose failover. So when I look for failover, I can actually, I can see it here, so failover. So that's one thing. The other thing I really wanted to show you a little bit is health. Actually, let me show you, yeah, let's do health. This is backend. It's not really advanced health checks. It just has a standard health check. Are you up and running? Yeah, you're up and running. Good. What we can do is to go to the front end that has a bunch of things implemented. So here I have actually 4 different ones, and I annotated, I added string in the front to actually show you what it is. So there are 2 liveness probes, 1 readiness probe, and 1 just a startup probe. The startup probe is very, 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 it's nothing to really brag about. It looks like this. It always returns, it's like kind of like a dog. It's always happy to see you. It just says, I'm up, good, okay. Well, that one you can probably implement in a bit better way. But liveness probes, that can be fun. So here, again, I'm doing not really a rocket science. I'm doing, I do use a little bit of configuration file. So the question was earlier, how do you specify default values and stuff? So you can, for example, if you do config, you can specify them here. That's your last line of defense. You can do default value. Because if it's not specified anywhere, it will going to use that value. But here I'm just checking for response code. And if the response code is 200, I say I'm good. And if it's anything else, I say I'm not good. There is also a similar one for response time, which is basically saying, okay, if the time is elapsed less than 3 seconds, we're all good, because this is what I defined as my SLA something something. But if it's above that, something is wrong, so something is happening, and then you actually tell that. So to show you that, we have a handy feature called delay. So we're going to turn it on, and now at some point, again, kind of at random, it's gonna fail. So now you see it's already spinning, so it seems like we're about to fail. It just needs a few more seconds to do so. Yeah, so critical service high is too slow, and it actually gives me an error. So you can use that and then you can use tools like Prometheus and stuff to have a look at all this and to scale up, scale down, do something. Maybe liveness probes usually are like, are you actually doing okay? If not, maybe you need to be restarted. Maybe you need to be scaled up or something like that. The other thing is that what we can do is we can actually say Docker, can we stop something? Like Docker stop. Okay, it should be stopped now. Yep, it is. Okay, exited, good. So now if you refresh this thing, now we have a down status as well. So critical services actually stopped responding. So we have another information in this as well. So this is, the cool thing is that you actually get all those kind of things just out of the box. And if we go at GitHub, this one, I have a bunch of links where you can actually see. So the one more thing I want to show you is Open API. That was funny. Oh, that's because, yeah. When you kill your services and it stops working, that's weird, right? Come on, I know you want to. Yeah, there we go. So now we have Open API. So if you've used any tools that talk to APIs and do these kind of things, they usually are based on the Open API spec. So it actually has a good description of things. That descriptions, that's the one you saw over here. Where is it? Not there, but in my... there. So that's basically what you saw in the annotation. Sorry, it's the wrong class here. So this is the operation, backup messaging service, backup messaging users, failover, blah, blah, blah. This is what you're seeing here. So you can actually automatically document your code as well without doing anything. You just added 2 lines to your method. This thing is just generated for you. And then you can choose the format. So I'm choosing JSON, but you can do something else as well. All right, we're almost out of time. I think we have like 2 minutes or so. Any questions, anything that you want me to show on stage? Or if not, then we can talk a little bit more about this later. I'm going to go back to my presentation because I have one last slide, is that how you can find me. This is me on Twitter. You can ping me there anytime. DMs are open. And yeah, that's pretty much what I have for today. Any questions, thoughts, comments? Did you learn something new? Do you want to try something new at work, at home, on your hobby project? Run your pet project on a Kubernetes cluster of 3 nodes. I know you want to, but the electricity bills are high, so. Anything? Okay, good. There is one, yes.
First of all, very good presentation.
Thank you very much.
I have a question about feature toggling.
Yeah.
You said you could use that to make gradual releases.
Mm-hmm.
So, and then you also said that those feature toggles should be removed as to not have
Mm-hmm.
feature toggles.
Mm-hmm.
But you also said earlier that the feature toggling could be used for different geographical locations to serve different interfaces. Is that a contradiction or?
Yeah, so the question is, a good question. So the question is that when I talked about feature toggles, I said that you should remove them, but I also said that they can be used for geographical locations and also for, what did you say? For like different user groups and stuff. It's not, and if the question was if it is a contradiction because they're kind of contradicting against, well, against each other? What do you say? Towards each other? Yeah, contradicting each other. That's what it's called. But yes and no. I mean, yes, kind of they're contradicting, but you don't really need to do it all at once. You can pick one of those, and then you just do that. But you really need to clean up your feature toggles that you know that are going to stay always on from some point in the future. You're just like, okay, we tried this, we had this experiment, we're done with the experiment, we don't need this feature toggle. We're going to remove the code that is not going to go further, and we're going to remove the feature toggle, for example, right? Or when it comes to geographical locations, if that's the point that it will stay there, it will actually do the difference, yeah, you need to keep that. Obviously, you cannot delete it. But my idea was to try to clean up things that you don't need anymore, because otherwise you'll end up, I know about, like I've read, and pretty much most of you probably have read stories of servers in a server rooms where a huge company moves and there is one server in a server room stands blinking and nobody is like, we don't know what it does. We cannot touch it. We just use a lot of money, use a lot of things to keep it running while we're transferring it somewhere, and we're going to put it there and just forget about it. And this is, we've seen all those legacy servers nobody dares to touch. If you do that with your features be like that, and they will be like, this is a holy feature. We don't know what it does, but when you turn it off, world goes black, like pitch black. So, this was the point. So clean up things you do not need, so the future generations kind of stop worshiping features that, So did I answer your question? I mean, it's...
So basically we have more like temporary feature toggles for users,
Yes.
building, testing, gradual release, and we have more like permanent feature toggles.
Exactly. So you have to separate between temporary feature toggles and the constant kind of that's going to stay there for some time. And you can do this here. You can do, like, for example, in this case, you can actually do different ones: experiment, release, operational, kill switch. Nice. And you can also do permissions. So say all the administrators, they're going to see this interface, all the other ones see the other thing. So this is, you can't really remove. But experiment, yeah, that's like a short-lived thing, right? So, but again, this is an example of a tool. There are a bunch of other things, but think about those things. Think about cleaning up things that you don't really need. And that goes in general. And please do not comment out your code and just commit it. That's, I know you might need it, but there is this thing called Git. I've seen that. I've seen like commented out bunch of like really long pieces of code, and you're like, why do you keep? Well, when I need it, I can just copy. No, you have source control, you have file, you have code control, code. You have Git, you have SVAN, CVS, if you use that, if they're that way inclined. Don't care, but you have some kind of code control or source control tools to do that. So features, code, delete things. It's okay. Anything else? No. Okay, thank you very much.